examples? Your job's to tell me to stop the video. Okay, ready? I'd like you to connect the 1 to the 1 dimension, right? What's called scale factor. Now we started by doubling the edge. So that's 1 to 2. So right by this, just write 1 to 2. Okay. Now I'd like you to box the surface areas, connect them. I'd like you to reduce. You have 10 seconds. Someone's going to give me the ratio. Jake, what's our ratio? 1 to 4. So what happened there, guys, is we doubled the edge length.
Oh my gosh, I told you guys to quadruple. No one listened to me.
All right, let's see what happened. Ready? No. Most people said that. I like you to circle your volumes now. Circle your volumes. And connect the volumes. You don't have to reduce. Look what happened to the volume, folks. We doubled the edge length. There's a pattern here. Pack your baggies, put them in the back. All right, guys. Lights, please, for me, Eli. We're at the top of the right-hand side. All right, guys. Top of the right-hand side. Here we go. Scale factor. Scale factor, by definition, is always the comparison of the first dimension. Scale. That was a 1 to 2 ratio. We're on the right-hand side of page 2. Our surface areas was 1 to 4.
1 to 4.
Our volumes were 1 to 8. Here's what's going on. When you change ratios, you change dimensions. Write X and Y for all of these. In the first dimension, it's like X to the first, Y to the first. So our X to the first is 1. Our Y to the first is 2. Second dimension, you square. 1 times 1 is 1. 2 times 2 is? Great. Third dimension, you cube the ratio. 1 times 1 times 1 is? 2 times 2 times 2 again. Nice job. Okay, so watch, guys. When you change dimensions, you change ratios. We're going to do 4 problems together, but I'm going to have you skip a couple problems, so let me show you which ones I want you to skip.
Oh, yeah.
Find problem 4, please. Just 4. Cross it out.
Hello.
I know crossing stuff. Example 4, not example 3, example 4. Flip over to the coffee cup, cross out the coffee cup. All righty, guys. Back to example 1. We're doing that right now. Step 1, put your finger by the word test. I want your finger actually on the paper. Read that with your lips moving. Go. Okay, right, scare, S-C-A-R-E. That should ring a bell. Ratios equal. Okay. I'm gonna go. President may get away with that, but we don't get to. Okay. All right, folks. Now, to test, we compare like lines because the ratio is equal. This is the easiest thing. Pay attention. I'm sorry, Dimitri, your attention's this way now. Cheyenne, Sal, Eli, attention's this way. Trace, 7 and 28. Okay, you've got 10 seconds, and give me the ratio. Great. Sal, 728. Reduce. What is it? Try it again. 7 to 28, sir. It's okay. It's 100. Yes, sir. So cross out. We put a 1 there. Cross out. Put a 4 there. Ready? Everyone else? And it's math 12. You've got 10 seconds. Do not say it out loud. Okay, Julia, what's the ratio? 3 to 12. The green there. 3 to 12 there. Just talk to me. 3 goes into 12. How many times there? Thank you, ma'am. So this is a 1 to 4. So this is a big fat yes. They are similar. Fabulous. You guys, by yourself, do not ask a neighbor for help. I'd like you to test the cones. Go. Test the cones. Mm-hmm.
Does it have to go down to 1?
Go as low as you can go. Low as you can go. Test yourself, folks.
Big. I told you. Yes. Light work.
Why were you wrong? Okay, so guys, guarantee those become wrong because you not trace a like line. So 40 was a radius. Fabulous.
The guy was like, that's wrong.
All righty, you tell them. All righty, guys, ready? Number 2. We'll do 3 more. I'd like you to put your finger on the paper where the word 2 is. Read that with your lips moving. Go.
Just report the term series have a ratio of 16 to 9. The volume of the larger prism is 236, when the volume of the smaller.
Okay, let's summarize what we have. Underlying surface area. Immediately identify the dimension you're working at. Underline the word ratio.
Ratio.
And that means since you're in the second dimension, that technically is your y squared, x squared, y squared. Volume of the larger, this, find the volume of the smaller. Let's transfer our numbers down. Volume of the larger is 256 meters cubed. Volume smaller is our unknown. Watch what I do, guys. I just accounted for this information.
Whoa.
Now I'm going to come over here. My 9 second dimension. I go like this. X squared, y squared. I have now accounted for this information. If you're reading your problems properly, you read with 3 body parts, you filter, process. Now, step 1. Yes, sir. What's up? You probably are. Exactly. It goes in 2D because of surface area. Arisha, why did I stick 16 and 9 to 2D and not 1D or 3D? Lovely, dear. So we need to backtrack, folks. So right now you're asking yourself this: if x squared is 16 and y squared is 9, you are currently calculating x and y. You've got 10 seconds. Do not say it out loud.
Don't say it, Andrew.
Rex, what's our x and y, sir? Yes, you're so correct. 4 and 3. Now we go forward, bounce. Now that you know your x, calculate x cubed, y cubed. What's that, dear? 4 times 4 times. Lovely. Good job with the mental math. Okay, 64. Alrighty. 3 times 3 times 3, mine. Lovely. Okay, folks, because we're dealing with similarity, every single one of these, or almost 90% of them, is going to boil down to one of these. Label your
Oh. Label your proportions.
So right now, I'm going to work left to right, so I'm going to write the word large to small. Large to small. Notice I labeled my proportion. Now, I'm going to do 256 over unknown. Therefore, I'm using my 3D volume. At this point, you may grab a calculator, cross multiply, solve. You got 30 seconds. Miss Clark, what'd you get? Want to wait what, kiddo? Lovely. Fabulous. Fabulous. Okay, we're going to do 2 more. Okay, example 3. Put your finger on that word 2 with your lips moving. Go.
2 solids are favorite.
That would be best. Some of them would be, yes. Okay, guys, ready? Underline surface immediately put 2D.
2D.
Underline volume, put 3D. We're on number 3 next. Okay, this one, we have to work backwards. Take your surface areas. We have the actual surface areas, not the ratios. So the first thing you need to do is divide both of these by the same number until you get them to the lowest form. Go. Take same number, down to the lowest form. That's the ratio. Okay. Lowest ratio. All right, William, you got it? What you got? 9 and 1. Thumbs up if you got 9 and 1, folks. Yes, fabulous. That's 9 and 1. Now, I want you to backtrack to 1D. Go. Backtrack, 10 seconds. Jaden, what's your 1 dimension? Let's just do the square root of 9, sir. 3 and yes, you got it. Okay, now bounce it over to the 3rd dimension. You have to do all 3. 10 seconds. Cheyenne, give me the 3D. Okay, let's just do it together. 3 times 3 times 3 again. Lovely. There we go. This one's 27 to 1. Okay, now we're back to a proportion. I'm going to do solid 1. Fabulous, Nakai. Solid 2. So I am going from solid 1 volume, 162 meters cubed. Solid 2 volume, don't know it. But since we went this direction, that is going to be a 27 to 1. Yes, you may have a calculator. You got 30 seconds. Okay. I know you've been pretty miserable with allergies. I apologize. Okay. Fabulous. Ethan, what'd you get? No. I got it. Just the volume, sir. The volume. After you cross multiply, what'd you get? This guy right there. Did you use 27 to 1 or did you use 9 to 1? Okay, let's get your calculator out. Basically, do you see it's going to be 162 divided by 27, sir? Go ahead, do that on your calculator. 162 divided by 27. What'd you get? 6 it is. 6 meters cubed. Alrighty, guys. I think we need one. So we're actually going to get stuff done. Page 7. We're going to do the first problem on page 7. I'm done with examples, folks. Bounce over to page 7, please. Not quite done. No, let's get through this one. Ready? Put your finger right there.
Actual volume. I got the ratio.
This one's a little bit trickier. This time you are given the volumes and we're backtracking to the surface area. So first thing, you need to divide the volumes and you are getting from the volumes the 3D ratio. The two numbers can't be divided anymore. Sorry, yes, sir. That's exactly what we're going for. Okay. Ready? Eli, what'd you get? Okay. Well, I'll come back to you, Eli, in just a moment. Striker, what'd you get? That is correct. Thumbs up if you got 27-1, folks.
Yeah.
Okay. Now you have to backtrack from the cubed root all the way back so it looks like this. What number times itself? 27. What number times itself 3 times is 1? Backtrack to the first dimension. It is once you kind of get the hang of it. First dimension. Okay, so Matthew, what's our first dimension? 3 to 1. Grant. Okay, 3 to 1. Eli, what would our second dimension then be? There, we got them all. Now we come over here. We look at what we want. We want surface area. We know that's 2D. I am going solid 1 to solid 2. 153 inches squared, unknown, equals 9 to 1 because it is 2D. Cross multiply, solve. And what I want you to do is finish just this page. Check it. Backtrack to page 5, folks. It's a whole number. No, don't check it yet. Finish the whole page. There's one more problem. You finish the whole page? Okay, you may. All righty, guys. Satellites, please.